Hi there, and welcome to Telefunken. Today's video is our first in our series on the Roland CR-78. The CompuRhythm CR-78 is a vintage analog drum machine first released in 1978. It's been billed by some as Roland's first famous drum machine, a designation that reflects the extent to which it was embraced by several pop musicians at the time and features prominently in contemporaneous hits by Peter Gabriel, Phil Collins, Hall & Oates, Roxy Music, Blondie, Soft Cell, OMD, Gary Newman, and even the Cocteau Twins. Although less powerful and more difficult to program than some of its XOX box cousins, it's nonetheless earned a place in the Roland pantheon due to its unique sound, described as an almost clinical, robotic tone that's favored by electro, minimal techno, and ambient electronica musicians to this day. The CR-78 features 34 preset rhythm patterns and a series of 16 selectable preset fills. What really distinguishes the CR-78 from the other drum machines available at the time is the ability for users to program and store their own patterns. The CR-78 allows users to store 4 custom patterns in SRAM memory that's maintained when the instrument is turned off by a rechargeable battery. This, and the ability to keep time with an external clock, made the CR-78 seem like a real musical instrument, rather than something designed to accompany the home entertainment organs that were popular in the 1970s. The brains of the operation is a mask-ROM encoded NEC microprocessor, the MUPD 8048C. Though the 8048 and the CR-78 was made by NEC, the 8048 was actually developed by Intel as part of the MCS48 series. Released in 1976, the 8048 was Intel's first microcontroller. It has a whopping 1 kilobyte of 8-bit ROM, mask programmed at the factory, and 64 bytes of RAM. It was used in the original IBM PC keyboard as a keyboard controller. It also found its way into later musical instruments such as the Roland Jupiter 4 and the ProMars, as well as the Korg Poly 61 and the Trident. The 8048 has its operating system in preset patterns stored in factory-coded mask ROM, while it relies on an outboard EPROM and 2 SRAM chips to manage the task of storing and accessing user patterns. The 8048 in the CR-78 is designated 8048C-015, and the 15 denotes the mask ROM programming for the CR-78. If you're looking for a replacement CPU for your CR-78 and come across this chip on the used market, just make sure it has this designation, as any other chip won't have the software needed to make the CR-78 work properly. Curiously, the CR-68 uses the same CPU with the same mask ROM programming. The software that differentiates the CR-78 from the CR-68 and that which supports the assembly and storage of user programs is stored in the CR-78's EPROM. The EPROM, or Erasable Programmable Read-Only Memory, is an Atmel AM2708, 1 kilobyte 8-bit NMOS EPROM with a UV erase window. If you open up your CR-78 and find the window on this chip exposed, you might want to place a piece of black electrical tape on it to avoid inadvertent erasure. This chip requires 3 power supplies, a 5-volt, a 12-volt, and a negative 5-volt supply, and it's because of this that the CR-78 requires a regulated negative 5-volt rail in addition to the positive 5 and 15-volt supplies. The SRAM in the CR-78 is a contemporaneous MUPD 5101C, a 1024-bit CMOS SRAM with 256 words of 4 bits each. 2 SRAM chips are used to bring us to the equivalent of 1 kilobyte of 8-bit RAM. CMOS static RAM requires the use of a small amount of power to maintain memory, 10 microamps, that must be drawn from the rechargeable battery soldered directly to the logic board. The CR-78 uses analog drum voices that in some cases sound very little like real percussion instruments. In my mind, this is part of its enduring charm. Most of the skin drum hits are comprised of pure sine wave tones with a percussive amplitude envelope superimposed on top. The metallic sounds are derived from a noise generator circuit coupled to additional shaping circuitry. The CR-78 allows the user to customize the preset rhythms by changing the mix between some of the individual sounds, altering the volume balance between bass and treble, cancelling some sounds altogether, and adding what's referred to as a metallic beat, comprised of 3 filtered square waves combined to create a distinctive chime. This flexibility, combined with the ability to mix more than one preset pattern and select from several preset fills, allows the CR-78 to be used in a performance mode that would have been revolutionary at the time. The CR-78 has an analog knob for tempo control, but will also accept an external V-trigger clock, allowing tracking to several vintage music sequencers, and with the right hardware, it can even be made to track to some modern DAWs. The biggest letdown in terms of integrating the CR-78 into modern studios is the lack of MIDI control. Aspiring programmers are forced to enter their patterns using one of a handful of input methods. The most straightforward is the use of an external peripheral, the Roland WS1 box, which was an optional extra available when the CR-78 was first sold. Unfortunately, the WS1 is now quite rare, and the going price on eBay seems to be more than $1,500 US, almost as much as the drum machine itself. Aftermarket, third-party versions of the WS1 do exist, the most notable the CR-78 PGM from CHD Electro Service, which also allows for input of MIDI or DIN sync clocks. This device currently sells for a much more reasonable 164 euros. For about the same price, or even less, one of a number of MIDI kits can be sourced for the CR-78. These take various forms, but typically allow for MIDI triggering of individual sounds, with some conferring velocity sensitivity. Coupled with the ability to modify a CR-78 to allow for individual output of specific drum sounds, it seems increasingly rare to find a CR-78 that retains the original unmolested rear panel, as most appear to contain extra holes in the chassis to accommodate modification. This is but the first installment in a series of videos on the CR-78, but later we'll revisit the subject of MIDI kits and install one. This series will follow my typical pattern, where we examine an instrument that's known to have some issues, we find out what's wrong, fix it, and set about calibrating the instrument to make sure that it is working as well as it did the day it left the factory. We'll be diving into this instrument in considerable detail. I hope you enjoy this series as much as I did making it, and as always, your comments, feedback, suggestions, and questions are most welcome. Let's get started. We're looking at a Roland CR-78 drum machine, and it's in really pretty remarkably good shape given that it was made roughly in 1978. So gosh, what is that? That's more than 40 years ago. The CR-78 is, or has been referred to as, Roland's first famous drum machine. This one, having come from Japan, has a power supply that runs off of 100 volts, and so it will need to be converted. I also know that it is not working, and it suffers from some damage that we'll cover in gory detail a little bit later, including damage to the printed circuit board by virtue of having a battery leak all over the circuit board and degrade that circuit board. However, cosmetically, it's in pretty darn good shape. You can see all these buttons are present. They appear to be working properly in that when we push one in, it cancels the previous selection. You can select more than one rhythm on this device and combine rhythms. It's one of the features that is quite popular. These are the programmed rhythm selection buttons, various selection switches, of course. These slider potentiometers may need some attention. The only real damage that's obvious to me, and it remains to be seen whether this is damage at all, there appears to be what could be kind of almost cigarette burns on the surface. Smoking is to this day quite popular pastime in Japan, and it's not uncommon for an operator of an instrument like this one to have a cigarette in between their fingers and kind of keep it there while they're trying to change settings on an instrument, and that's how you might end up with burns on the face of the device. Hopefully that's not the case, and hopefully I can clean that off. There's 1, 2, 3, 4 areas that seem to suffer from something like that. Maybe that's what it is, maybe it's not. Other than that, it's in pretty darn good shape. There's a little bit maybe of corrosion on the outside of these switches. I can probably polish that off. But really it's the inside of the instrument that is likely to require the most attention. I'm just going to turn it around real quickly and show you the back side. So here's the back side of the instrument where, yes, indeed, we can see that it's been built for a 100 volt service, and we'll need to change that. This is the original Japanese plate that goes on the instrument when it's manufactured. A little bit of corrosion on some of the jacks. That's kind of normal over time. And you can see that this clearly does not have MIDI. This predates MIDI. It really only has a start-stop, trigger, a variation foot switch, and then a high and low output. No individual outs. These can be modified to use individual outputs for each instrument. And then there's a couple of jacks here which facilitate programming using an external interface, which we do not currently have. You can see that the wood is kind of an odd plywood with a laminate, so we want to be very careful and not damage this case. So how do we get the meat or the bones of this instrument out of this case? Well, if we tilt it on its side, we can see a number of screws here, and that gives us a little bit of a hint as to what we're up against. And so we'll begin removing some of those screws with a view towards releasing the chassis from the external wooden case. By removing these 4 screws from the bottom of the case, we can simply push the chassis back and out of the wooden case, and it slides out like so. And we'll set the case aside. So this gives us a bit of a view of the instrument itself, including the aforementioned power transformer, which will be a little challenging, I think, to find a replacement for, one that's suitable for use in this country. The machine has, actually, I think it's 5 circuit boards. We have one below that we'll come to later. I think it's actually 6 now. 6 or 7. 6 or 7 circuit boards. We have one on the bottom. This is a so-called voice board, and we'll come to that later. This is the so-called logic board, a number of smaller circuit boards that decorate the front panel and the rear panel. However, this is the circuit board that is going to cause us the most problems, and it's because of this. This is a battery, and this battery is leaking, has leaked quite badly, and you can see that the damage has come into and damaged the traces that come off of this connector. So it remains to be seen whether or not we can undertake a full repair of this and fix this circuit board and get it back into operating condition. If not, we may need to actually replace this entire circuit board, which sounds like a fairly significant undertaking, and it is. There's a number of logic chips, there's a microprocessor, some RAM and EPROMs and the like on this board, and we need to make sure that if we take it apart, we put it back together so that it works like the day it left the factory. So this will be a lot of work, but it's worth it. This is a bit of a jewel, and it's worth restoring and putting back into the original condition. To make matters even more critical, this is an instrument that is going to a very good friend of mine, and so I want to do the very best job that I can in whipping this into shape. And so no expense, either time nor money, will be spared. This is a view of the voice board, which also contains some of the power supply. These are 3 bridge rectifiers, and these are the filter capacitors that support this portion of the power supply. We then have, of course, a number of fuses on individual rails, and then these will be the circuits that determine the voices of the individual voices in the instrument. Without further ado, I will set about examining the logic board with a view towards repairing it or replacing it. In addition, we'll probably be checking all of the electrolytic capacitors for ESR. Any other capacitors, coils and or resistors will be checked for continuity, and of course all of the transistors will be evaluated as well. This is exciting. I really love this instrument. I love the sound of the CR-78. It's one of my favorites. Maybe my favorite drum machine other than the 808. So can't wait to hear this playing. Well, that's it for today's video, an introduction to the Roland CompuRhythm CR-78. Future videos will include rebuilding the power supply, converting the instrument to North American voltage, replacing the logic board, and calibrating the instrument. Hope you found the video interesting and entertaining. Consider subscribing to the channel.